towers symbolize the progress of this nation of 22 million people. We are not a big country or a very rich one, but we build what we can afford. And we can afford the Twin Towers, as we can afford the state-of-the-art airport, Putrajaya, Cyberjaya.
Let's exploring Kuala Lumpur population growth using first-order differential equations.
Growth and decay can be described as predictable changes over time. Exponential growth occurs when something grows faster as it gets larger, like the compound interest or population growth, while exponential decay happens when something decreases steadily, like radioactive decay or cooling coffee. These ideas help in explaining the patterns of nature, science, and daily life. In this study, we would like to explore about population growth.
We are analyzing the population growth in Kuala Lumpur. According to the data, the population grows at a rate proportional to the population present at any given time. Starting with an initial of 261,528 in 1950, it was observed that the population increased by 2.764% during the second year. Now the project revolves around the population growth modeling with the following key objective. First, obtain the expression for the population at any given time. The second one, determine the time taken when the population reached 343,527, and the last one, determine the population in 25 years. This objective will help us understand and predict the population trends effectively. Let's dive into the methods and solution. Now, for the first objective, to obtain the expression for the population at any given time, we use the differential equation dP over dt equal to Kp. P represents the population at any given time and K is the growth rate constant. Then, integrating both sides, we get ln P equal to Kt plus C. C is the constant of integration. And lastly, exponentiating both sides, we get the general solution P equal to Ce power of Kt. Next, we need to calculate the value of C, constant of integration, using the given data. Substitute all this data into the general equation. And for your information, K times 0 equal to 0, E power of 0 equal to 1. Therefore, C equal to 261,528. Then substitute the value of C into the general equation. Next, we need to calculate the value of K, the growth rate constant, using the given data. Substitute all this data into the general equation. Then we divide both sides by 261,528. Simplify it and we get the value of K, which is 0.0136. Substitute the value of K into the general equation. In short, the final expression for the population at any given time, P equal to 261,528, E power of 0.0136t.
For the second problem solution, we need to determine the time taken when the population reached 343,527 people. To search for T, P will be equal to 343,527. As we can see from the third equation, we will be replace the P with the value from the first equation. After replacing it, make E as a subject by dividing 261,528 to the left side. Then put ln on both sides, then we will get T equal to 20.05 years.
For the last problem is we need to determine the population in 25 years by substitute T equals to 25 into the solution we get at first problem, which is P equals to 261,528 E power of 0 3.01360. Thus, we will get 367,433 people. So, for the conclusion, population growth in Kuala Lumpur is dynamically increasing within the years. It is vital for urban planning and development, economic forecasting, resource allocation, policy making, and lastly, tracking migration pattern.